let's now dive into this. I'm going to talk about science, going to talk a bit about mathematics, and then the amazing thing, which is the beauty which is visible. Who said this? I'm neither especially clever nor especially gifted. I'm only very, very curious. Well, some of you may know who this is. It's actually none other than Albert Einstein. So he had a humble attitude towards the matters of science, the matters of mathematics even, which of course he was very gifted at. He wasn't a Christian, but nevertheless, he had a humble attitude towards the science. And he said also the most incomprehensible thing about the universe is that it is comprehensible. So there are some things which are really striking, as we shall see in this talk, that mathematics actually makes, you wouldn't believe it, I know some of you, but actually mathematics, when it's done correctly, goes right across the board and exposes the reality or a model of the reality that we're looking at. We're going to look a bit at what it is to think abstractly, and then I'm going to look up a bit about the mathematics itself. How is it real? Then I'm going to go into a bit more depth about that point that I just made, that the mathematical ways by which we describe things occur in many disciplines. And then I'm going to move into the coherence of maths and the beauty of it, and then finally end on the fact that man is made in God's image. One of the very big witnesses against atheism is the very fact that there is such a thing as mathematics. Where did it come from? Where did the idea come from that you could represent what you're looking at or what you're playing with or whatever it is you're doing in electronics or right across the disciplines, and you could represent it by symbols which you could rearrange and mess about with, and then even make predictions and come out of that back into the real world? It's all to do with logical thought and the fact that we can think logically. Where does that come from? Mud left enough years, like billions, 13.7 billion years, will never on its own produce mathematics. It's one of the big evidences which shows to us that atheism is far from reality. The real reality is that we can think logically. Where did that come from? That came from a mind, which of course means we're made in God's image. So the nature of abstract thought. C.S. Lewis actually was converted by this very principle that I'm referring to. He was not, of course, a mathematician, but he was a great thinker, great philosopher, really, in his day. And for a long while, he was an atheist. He'd been fought in the First World War, seen awful suffering, very similar to some of the suffering at the moment in Ukraine. He'd seen people killed, and he thought there can't be a God with all that suffering. But then he came back, and some of his friends at college in Cambridge began to say to him, well, look, where does your thinking come from? Where does the very fact that you can think rationally come from? And he had no answer. He knew that he was being honest in his atheism in that sense. There are one or two honest atheists. One of the ones which we have today is the chap who wrote Mind and Cosmos, and he is very much ardent in his atheism, but actually his position is a bit like C.S. Lewis. He's never really been converted, as far as I know. I don't think he's even thinking about that, but he realizes that he can't answer every question, and he's in a position where he needs to be like Lewis and honestly admit, and he has in some of his books, his name's Thomas Nagel, and he sort of honestly admitted that atheism doesn't answer these big issues, and he may be open to somebody speaking to him. I hope that will happen on the gospel. He's from New York in America. So there are a number of atheists. Some, of course, are very rude, like Dawkins and others, just don't really even admit this issue. But there are some who do, even today. So he says, as we have seen, a train of thought loses all rational credentials as soon as it can be shown to be wholly the result of non-rational causes. So if your grandmother is sadly suffering from dementia in an old people's home and suddenly starts saying things which are not rational, you know that it's not the real granny speaking. It's because of, and people can track it back to some illness in the mind. That means there is a rational cause. So that would then immediately mean that rationality actually is not from the food you ate for breakfast. You cannot trace it to a material origin. It has to be that you're made in the image of God. It's actually a very important point. And in my booklet, which some of you may have, I think Joe may have it, and I know Simon has, are you really an atheist? That is one of the points that I make. A chap much earlier had the same head-on collision with atheism. He never became a Christian, but he said, if my mental processes are determined solely by the motions of atoms in my brain, I have no reason to suppose that my beliefs are true, and hence I have no reason to suppose that my brain is composed of atoms. That was Haldane, whose books are still used today in physical chemistry and other areas, but sadly he never became a Christian, but he saw the problem. And John Lennox, I don't agree with him on everything. I don't agree with his position on the days of creation, but he makes the point himself in one of his books, God's Undertaker. He says if there were any affinities between the nucleotide bases, between these in the DNA, then their information carrying potential would be drastically reduced. In other words, there would be a rational reason for saying that CAT comes together, which stands for a particular amino acid, which goes into making the proteins of the cell. So if you could say that there was a chemical reason that CAT came together, then you'd say, well, there is no language here. There's no information in the system. So it's a very important point, the abstract basis of language, this time in the cell, as against us, which we've been speaking to at this point, is a real indication that atheism doesn't work. The DNA molecule then has this system of communication, which is a bit like the language that we use in English, obviously, but other languages, which are built using an order of sounds that I'm using now, or if it's writing, it's squiggles on a page. And it's the same thing in DNA, which again is a marvelous witness that coding, abstract coding, this time in DNA as against coding in language that I'm using now, is a real indication that we are made in God's image. And indeed, the DNA shows that that is made by mind. So the fact that information is non-material is a very important issue. It's not defined by physics and chemistry. It's not defined abstract thought. It's not defined by the brain and firing synapses for people. And in the DNA that we've just been talking about, it's exactly the same issue. So we are not just, as Dawkins said, dancing to our DNA. It's total nonsense. He hasn't grasped that there is a major issue. In fact, he was cornered on this by an Irish interviewer once, where he pressed him, saying, well, if you reduce everything just to atoms, bouncing atoms, dancing to your DNA, then how do you explain where mind and intelligence and information comes from? And of course, he's got no answer. Let's move on then to mathematics. How is it real? Well, it uses, as I've just been saying, abstract information, but it's not communication with words. And neither is it really a communication with something like a Morse code, but there is a similarity, as I've been indicating, between that sort of coding system and our language. When we're talking about mathematics, it's coding using symbols. If I put these blanks, or these dashes rather, and dots to represent Morse code, it actually says John loves Mary, but in Morse code. I think Mary might prefer it to be in words, in the sand, as I showed you, rather than in dots and dashes. But it makes the point, doesn't it, that the same message can use different systems to be communicated. Well, mathematics uses logical symbols like pi, square roots, and all the stuff that perhaps many of you don't like. But I love it. I love the fact that you can represent intelligent communication very succinctly using symbols. And when you get something right, like most of you, will perhaps just have a vague familiarity with algebra. Maybe you've come across simultaneous equations, and you've got an X and a Y, and you've got to solve them, and you've got two equations, and how am I going to solve them? And then you do a few of these problems, you suddenly understand what's going on. I don't know whether you ever had that sense in your maths lessons that things clicked. Well, that happens all the way up in the mathematical complexity when you're doing things like horrors. You say differential equations. Oh dear, differentiation. I thought I'd left that behind me. Well, even when you start doing things like that and you do it properly, you can have a sense of everything clicking together. And Penrose, who's not a Christian, and he's really a sort of Platonic thinker, that is, he's following Greek mentality, but he certainly wouldn't say that we boil down just to molecules. And he wrote the book The Emperor's New Mind, and he rightly said, it's well worth reading that book, even though it's not a Christian book. I found it very helpful because he's arguing against the idea that Dawkins, of course, puts forward, that we all just come down to being molecules a few billion years old, and we're just bunches of matter and energy. And he's basically saying, no, that's not the case. There is something which is to do with mind and intelligence, and that's what the whole book's about. And he doesn't come to a Christian position, but he does accept that there is some reality which is beyond molecules, beyond matter and energy. And he makes this point about, in mathematics, suddenly something clicks and you understand it. That's the mind thinking in this way. If I've been concentrating hard, he says, for some while on mathematics, and someone would engage me in conversation. So this is a deep thinking mathematician. He is a clever guy. And he said, I would find myself, if somebody started speaking in English, which is not the language he's been using because he's been thinking about mathematics, I'd find myself almost unable to speak for several seconds. This is not to say that I do not sometimes think in words. It is just that I find words almost useless for mathematical thinking. And I identify with that point. When I was doing my PhD and I was trying to really solve what was quite a complicated mathematical problem, which I did in my applied maths PhD, I was really absorbed in it. And in the end, it eventually clicked. It took me a long while to get everything working, but eventually I got it sussed. And I identify with Roger Penrose when he says, suddenly it all clicks and you're thinking and you're even going to sleep with the mathematics going around in your mind. So is mathematics real? Mathematics, yes, is real, I'm saying. And it's not defined by matter and energy. Interestingly, of course, Dawkins is not a mathematician. Frankly, he's only written about 30, 40 papers. And one wonders, why did he get promoted in the way that he did, just to represent a public understanding of science, when, frankly, that was his position frankly, he hadn't really written all the papers that normally would be considered necessary to have a personal chair in your subject in zoology, which was his subject. I'll leave that, but suffice to say that Dawkins is not a mathematician. So I'm maintaining that the universe has a third fundamental quantity, which is information. Nagel, whom I mentioned earlier, in this book, Mind and Cosmos, says, if denying the reality to the mental continues to be unacceptable, that suggests that the original premise, please note this, materialist naturalism, is false and not just around the edges. This is why I think Nagel is on a journey. I'd love to meet him in New York. I often go through Newark, which is just over the river, and I've wondered sometimes about, I wonder whether I could sort of just say, can we meet at a Starbucks somewhere, you know, and just talk. I'd love to meet Thomas Nagel. I find him a fascinating writer because he really is on a journey, a bit like C.S. Lewis. And then he says, perhaps the natural order is not exclusively physical. Obviously, this doesn't make a person a Christian, but you get the point that I'm making, that this shows that there is something beyond just the physical. That's what he's saying here. We're not just physics and energy, you know, not just matter and energy. Now, let me talk about the uncanny connections across disciplines. A lot of you won't know these names. You asked me to speak on this subject, Joe, so it's your fault. But clearly, what I'm seeking to show you is that I'm just talking about the principles here. You don't need to worry about all the names that I'm quoting. But if you're going to deal with this subject of science and mathematics, then obviously I've got to deal with some of the mathematicians. Joe will give you a test afterwards, and he'll be doing all the marking. So he's the one to blame if you get 0 out of 10 for the test. No, I'm just joking. The miracle, he says, this is Wigner, who's died now, but he was a Nobel Prize winner in mathematics. He was from Hungary. And he says, the miracle of the appropriateness of the language of mathematics for the formulation of the laws of physics is a wonderful gift which we neither understand nor deserve. We should be grateful for it and hope that it will remain valid in future research and that it will extend, for better or for worse, to our pleasure, even though perhaps also to our bafflement, to wide branches of learning. Now, he's touching on this here, that when you get the mathematics carefully done, and you get it right, such that it really does reflect on what we call model. That means to make, how can I put it? Probably most of you don't understand the word model in mathematics. It means to represent, right? If one's talking about the flow of water, you can actually write down an equation which represents mathematically the flow of water, okay? Now, when you write down that equation, it's actually what we call a diffusion equation, which has a diffusion term and it has a term to do with time. Well, it's a well-known equation in physics. You suddenly find that it occurs in other branches of science, like in electrical engineering, like in not just water flow, but the flow of heat and many other things. And that's what he means when he says the appropriateness of the language of mathematics. Let me just jump to the Bible. You've heard of the number pi, which is 3.141, 3.142 or 141592653, and you can carry on and on and on with it. Some people have made their whole stage appearances on reciting pi to the n number of decimals. Anyway, in the Bible, it talks about this laver, which is the place for washing in the temple. And some people have raised issues because they say, well, you know, when you do the dimensions, the diameter is not a third of the circumference. Or loosely it's a third, but it's not the exact number of pi. And when you actually do all the careful work on this, and you think carefully about the outer diameter and the inner circumference, then actually you can make it work, because the numbers given in the Bible are 10 cubits and 30 cubits. So people who are purists and who are atheists look at the Bible and they say, oh, they got it wrong. It's not 3.14. They're saying that pi is 3, because S is the circumference is just 3 times 10. And they're saying very, very weak mathematics. But just a minute. It actually says that the laver height was 5 cubits, which is 7.5 feet. And when you actually just work out, it's a bit difficult to tell you here what I'm doing, but I'm trying to take account of the fact that what could have happened is that somebody was measuring the diameter, that's true, which is 10, and the circumference, and they may well have been measuring the outside circumference and the inner diameter. Do you see? So that then you've got to take account of the thickness. And it could well have been that the thickness was about 4.1 inches, because you're dealing with a very large laver. It was not a small item. Anyway, so the diameter at the top lip and the circumference lower down could also be one of the issues. That's another alternative to solve that little dilemma. Anyway, let me now just dive into some examples of mathematical constants. We've already mentioned pi, but there are 3 fundamental constants in many disciplines that constantly occur. You say, this is a differential equation. Ooh, we don't like this. But did you know that there is a function that when you differentiate it, you get the same function? And the function is what we call the exponential. And there is a natural, what we call base for this function, which is e. In other words, it only works when you're dealing with e to the x, that when you differentiate it, you get the same function, e to the x. And the number, which is a well-known constant in mathematics, is 2.71828 and so on. We call that e. I've just talked to you about the laver in the Bible, and the diameter, or rather diameter times 3.14159 will always give you the circumference of a circle. So we call that number pi. Now, these 2 numbers, e and pi, are actually related, but it's not obvious how they're related. You say, I don't want to be doing imaginary numbers. And probably most of you perhaps have never come across the fact that there are what we call imaginary numbers. And you might say, this is just gobbledygook to me, Andy. Or just a minute, hold your horses. Supposing we represent the square root of -1, which is you can't do normally, you can find the square root of 2, you can find the square root of 3, but once you go on to negative numbers, you can't find the square root. But if you define I as your basic unit, where you say, okay, I'll represent the square root of -1 by I, then there is something which we call Euler's identity, where amazingly that when you do imaginary exponentials, e to the I pi is actually -1. So e to the I pi plus 1 is equal to 0. And it's called Euler's identity. Now, I'm not expecting you to remember all this. What I just want you to see is that when you do the maths correctly and you have imaginary numbers, and I'll tell you how they work to the real outside world just in a moment, but just bear with me. If you actually do the maths properly, you get a connection between e to the ix cos x and sin x. And when you actually make x pi, that number pi, then you actually get that e to the I pi plus 1 is 0. In other words, there is a connection between e, pi, and this square root of minus 1, okay? Now, you might say, surely that's just esoteric nonsense. You know, it has no bearing on the everyday world. Actually, it does. Next time you go on an aircraft and you see the engine beginning to start of aircraft nearby, or maybe you can even look at the engine of the aircraft you're just about to go on, you'll see that it's going round and round. And Rolls-Royce have to design those engines with fan blades and all the rest of it, and they have to go into an awful lot of physics to make sure that that engine is going round properly, and anything which is involving rotating motion in electrical engines, in gas turbines, which is what a jet engine is, involves mathematically formulae which are representing the circular motion by a position on, if you look at this graph at the bottom here, I'm using my cursor, I don't know whether you can see it, but if you look at the vertical axis, it says imaginary. So anything which is going round and round, okay, has a number on this axis. I won't go into all the detail, but that's how you do it. And then if something is perhaps going a bit wrong, then this circle will begin to expand. In other words, the real part of this number, whatever it is we're representing, circular motion, begins to show what we call an instability. I won't go into all the detail, but the mathematics of engines or anything rotating involves complex numbers or imaginary numbers. And I've put here, this I is used in understanding anything which in engineering is cyclic in behavior. Now, let me just show you something else. Surds means when you've got a square root and you cannot resolve it and just sort of put it as a ratio of some numbers like 1, 2, 3, 4. And it means that it's a number which is never properly precise. You can go to as many decimal points as you can, but you never feel that you've actually totally resolved it. Pi actually can never be properly resolved. People have actually made their living, as I said earlier, by reciting pi. Well, so it's 3.141592653. I can get that far. Then it's 5897, then 9323. And people could go on and on reciting it on the stage. I don't know why they get paid for it, because frankly, it's just a lot of, you know, you're just holding numbers in your head for no reason. But let me just show you that there are some fundamental algebraic relationships which are extraordinary. I don't know whether any of you have ever done quadratic equations where you write down something that you don't know, like x, but you know it's connected with something you know, like a, b, and c, and it's also connected with x squared. So you've got to actually solve for x when you know that ax squared and bx plus c is equal to 0. And you probably knew this formula, some of you, while you were still in your nappies, but there is actually a way of writing down the solution, that x is equal to minus b plus or minus the square root of all b squared minus 4ac all over 2a. Now, that quadratic that I've just written down occurs right across the disciplines again. And get this, it has complex solutions. So I'm diving into some mind-stretching stuff here, I know, but let me now I'm moving into the area of beauty, because the connections of geometry and key ratios is linked partly with the pi that I mentioned and another number which is called the golden ratio. In order to work this one out, we need to look a bit at Fibonacci series. You actually found today, Christina Mitchell found a nautiloid. We're going to refer to that in a moment. But the nautiloid actually has, it's using a ratio, which I'm going to define in a moment as the golden ratio. But we need to look at some series first. Supposing I have two numbers, 0 and 1, and then I just add them, 0 and 1 gives you 1. Write down the 1, which is the third number here. Now you add up 1 and 1, it becomes 2. So you write down the fourth number as 2. Now you add up 2, the number before it, which is 1. You get 3. You add 3 and 2, you get 5. 5 and 3, you get 8. 8 and 5, you get 13. And so on. And it goes up like this, 21, 34, 55, 89, 144. And the number divided by the previous number, initially it's 1. Then it's 2 over 1, so it's 2. Then it's 3 over 2, which is 1.5. Then it's 5 over 3, which is getting a little bit complicated, so it's 1.67 or thereabouts. Then it's 8 over 5, so you're actually getting 1 3/8 and so on. You'll find that as you go on here, it gets closer and closer to what's called a golden ratio, which is 1.618. And you can write it down to any decimal points that you wish. Amazingly, the inverse of the golden ratio, 1 over big phi, is 0.618. That is an interesting point. It has the same bit after the decimal point, but it doesn't have the 1. Well, supposing we've got two, we split a line in two, and the b over a, that's the b, which is the larger part, divided by the a, which is the whole line, that we make phi, which is the 0.618. So the ratio of the larger part to the whole is a minus b, which we just said, to b. So we actually get that the ratio of the smaller part to the larger part, which I'm just defining, just saying a minus b over b. But remember that we said that b over a, we're going to say is 0.618. So because of that, we know that b is phi times a. And if you actually write down the mathematics, you end up with a formula which actually shows to you what phi must be when that happens, such that the ratio of b to a, or rather a to b, b to a, which is the whole line, is the same as a minus b to b. And that actually ends up being the golden ratio. So we have here an interesting concept that the golden ratio can be related to geometrical shapes. Supposing we make the width of this rectangle that I've just put up b, then that becomes amazingly the shape that you find in nautiloids, and it just comes out naturally. You even find it on some spiral galaxies. We then have an interesting situation that the angle that is swept through when you go part of the way around the circumference, that is the golden ratio part of the circumference, the 0.618, that angle is 138 degrees, or just under 137.5. And of course, the outer angle is 360 degrees minus that. And we constantly find that this angle is used in flower petals. We also find that the Fibonacci numbers occur naturally in pineapples that you can see here with their seeds, which form diagonal lines, both from right to left at a shallow angle, and from left to right at a steeper angle. In fact, there are 3 in any grouping of seeds, like you get in pineapples and in sunflowers. you'll find that you'll always get some of the Fibonacci numbers. In other words, the golden ratio and the Fibonacci series occurs naturally in the world of plants. You also find that, as I've put here, that people who've done art in the past have often used the golden ratio. Notre Dame Cathedral, and indeed the Mona Lisa done by Leonardo da Vinci, has all sorts of Fibonacci and golden ratio terms which make it very beautiful. The pyramids use the golden ratio, and amazingly, on the feather of a peacock, you've got the eye of the peacock, which is frankly amazing, because you find that the position of that central, very dark blue part to the overall position of the brown parts is roughly in the ratio of the golden ratio. It's really quite extraordinary. And when artists are doing pictures, you find that they often shift the center just slightly to the right. And guess what? If they're good painters and good drawers, they will actually be doing it by roughly the golden ratio. Even music has Bach sometimes writing his compositions with the golden ratio in mind. The original musical keyboard was also using numbers from the Fibonacci series, such that the minor third, the major third, the fourth, the fifth, the augmented fifth were using ratios which are to do with those Fibonacci numbers. Today, of course, we don't quite have pianos exactly like those original frequencies. The reason being that you couldn't then transpose on the original keyboards, which had that frequency that I've just put there in the third column. So in order to enable you to transpose, you're barely aware of it. The frequencies are only slightly different, and it enables us to move from C to A flat to E flat major and so on. I'm going to leave that quote because I want to make sure I just have a bit of time. Just other examples of symmetry. Did you know you can write the numbers such that 1 times 8 plus 1 is equal to 9, 12 times 8 plus 2 is equal to 98, 123 times 8 plus 3 is equal to 987, and so on. And you get this series on the right. That's because we're using base 10. And of course, this will only work with base 10. If you're using a different base, you'd get a different examples of symmetry. Here's another one. 1 times 1 is 1, 11 times 11 is 121, and 111 times 111 is 12321. The next one is 1234321, and so on and so forth. It's really quite remarkable. Now, I'm not going to go on too much about this because it does get a little bit hairy with some of the mathematics. But you know, I mentioned that there are various differential equations. Well, you remember I mentioned the diffusion equation. Well, that diffusion equation is actually written there in 3 dimensions. And I said to you, it represents fluid flow, but it also represents heat, and it represents electromagnetism. The wave equation is remarkable because that wave equation represents water waves, it represents sound waves, and many other types of waves in physics. It is ubiquitous. We get it in sound, light, radio, electromagnetism, water. Einstein said, how is it possible, that mathematics, a product of human thought, fits so excellently the objects of physical reality? Well, mathematics unlocks the principles of the universe. Johann Kepler showed that he could describe the motions of the planets with mathematics. And more recently, Dirac actually was able to describe quantum mechanics using mathematics and use it to even predict what people should find if they hunted for it, which was a positively charged electron. So there is some meaning here which shows that mathematics is extremely powerful. Now, I'm not going to do the second one. I'm just going to do the first one. So here's a slide on Dirac, okay? So as I said, he worked in quantum mechanics and he solved a wave equation, which I've written up there. And it's a wave equation on one side, and then it has a forcing term on the other side. That describes the motion of electrons, okay? But he found that there was two other solutions. And he said, there is a positively charged electron in this equation. Would you believe it? That people then actually found those particles because Dirac said that they must be there. As I said, I'm going to jump this bit because I don't want to bore you with too much detail here. And I just want to mention, as I just referred to it, that in terms of gravity, Kepler took the laws of Newton, which were to describing gravity, and also the simple formula that Newton found, which was the force of gravity between two objects of different sizes. You might call the capital M in this equation the mass of the sun. The little m is the mass of the earth. R is the distance between them. And the capital G is what we call the gravitational constant. Now, Newton found that, but using Newton's ideas, Kepler brilliantly worked out that the time period taken for going round the arc of an ellipse, which is what really happens with the planets going around the sun. The Earth, it's almost circular, but they're not all completely circular. Pluto and Neptune have highly irregular orbits, and they're not circular. So he showed that the period is linked with the distance from the sun. And of course, another formula, which is well known by most of us, that Einstein showed from his mathematics, and it took him a lot of work to produce this, that the mass of an object can be transferred to energy, E on the left, and then the energy, once the mass is converted to energy, is the mass times speed of light squared. Well, that's an incredible finding. And furthermore, Maxwell, don't worry about the equations, and I'm being serious here. Although I said Joe's going to test you, I was just simply joking, obviously. But just to show you the power of mathematics, this gentleman, James Clerk Maxwell, was a Christian. He died at 49 or 48, 49. And he was a brilliant mathematician. He was a Christian from Edinburgh. He spent a lot of his time in Cambridge, and he had written over the Cavendish laboratories Psalm 111 verse 2, and it's still there today in Latin. The works of the Lord are great, sought out of all them that have pleasure therein. He took two equations for magnetism, which are the top two equations, and the bottom two equations for electricity. And in the 1800s, he put these together and realized that buried in them, there was a differential equation, which we call the wave equation, which I mentioned earlier. And he predicted the speed of light from that equation, which is approximately 300,000 meters per second. It had not been measured when he said that. Nobody had done it. A few decades later, it was measured. And it was exactly what Maxwell had predicted, because Maxwell said that in free space, if you know what the magnetic permeability of free space is, and he estimated that, if you know what the electron permittivity of free space is, you can predict the speed of light. He worked it out, said it's 300,000 meters per second. A bit later on, that's exactly what they got. So mathematics has a predictive power, and when it's done correctly, it has elegance and beauty. Roger Penrose, whom I mentioned earlier, said a beautiful idea has a much greater chance of being a correct one than an ugly one. And he's right. So when Dawkins says the universe we observe has precisely the properties we should expect if there is at bottom no design, no purpose, no evil, no good, nothing but blind, pitiless indifference, was he right? No. Because that same gentleman said, my brain is just a lump of meat. Well, that is a very ugly statement, because that's what the Nazis and other tyrannical leaders have believed, that my brain is just a lump of meat. I'm playing here Schindler's List, which reminds us of what the Nazis did during the Second World War. He said that to a friend of mine in Oxford High Street when he was met by John Hawley. He said this when John Hawley, who was a Christian, was arguing with him about where his mind came from. He said, my brain's just a lump of meat. In other words, he hadn't understood the very first point that I made, that where does abstract, careful rationality come from? It cannot just come from meat, as Dawkins maintains. An atheist cannot explain his own mind. Evolutionary naturalism, Thomas Nagel said, provides an account of our capacities that undermines their reliability, and in so doing undermines itself. That was my first point that I was making earlier. So remember what Haldane said? He never used his mind to lead him to Christ, but C.S. Lewis, who was an atheist, was honest and came to Christ. Let me now just close by saying this. Famously, Nietzsche said God is dead. By the way, Nietzsche wasn't actually saying that he believed God is dead. He was really just simply saying, look, if you take the philosophy that most of us have adopted, we're going to lose God in our thinking. We have killed him, he says. His shadow still looms. How shall we comfort ourselves? The murderers of all murderers. And that's the way he was arguing. He wasn't a Christian. But you need to understand that he wasn't actually saying that God was dead, although most people think that he was. Anyway, he wasn't a believer, and he was basically saying, we've killed the very origin of beauty. Somebody once put, after Nietzsche had died, Nietzsche is dead, God. And of course, that's exactly what's happened. Most people who are atheists, when they die, have no understanding of the illogicality of their position and that God has the last word. So is it mud to mathematics by mindless evolution? Where do we have beauty? Well, there is marvelous beauty that I've been describing, and I'm just going to move this on and to say that that beauty doesn't actually have, and that elegance doesn't make any sense if atheism is true. But it does make sense if we understand that we're made in the image of God. We are actually a reflection of God's own transcendence. We have the ability to do mathematics. And beauty is an expression of our being made in God's image. Mud cannot produce logic, mathematics, and beauty, and the amount of time you have will never help. So my conclusion is that we are made in the image of a transcendent God, just as the Bible says. This gives the basis for rationality. It gives the basis for beauty. It is also means that we are responsible before a holy God. And that's, of course, why the atheist doesn't want where this is going. That's why Thomas Nagel is fighting it. In John 1, it says, in the beginning was the Word, and the Word was with God, and the Word was God. The same was in the beginning with God. All things, including mathematics, were made by him, and without him was not anything made that was made. I rest my case, ladies and gentlemen. The greatest truth is that that same Creator became our Saviour and went to the cross, which we can only understand by reading the most wonderful of books, which communicates the deepest truths of all, which is not mathematics. The deepest truths are the theology of Christ and his death on the cross, that we might be forgiven. Thank you, Joe, and thank you to you all. There may be one or two questions. I've left 2 or 3 minutes for that. Thank you, Joe.
Thank you very, very much for that, Professor Andy. Yes, we do have 1 or 2 minutes for questions, so we will definitely take some. I have the extra long microphone lead, so we can move it around the room and take some questions. If you just want to stop sharing for a second, so we can get you up on full screen, so that you can see everybody and everybody can see you. That's better. Lovely. All right, let's go and see if anybody has any questions.
I can see Diane eager there.
Yes,
she's going to ask some naughty question. Hi, Diane. You've got some nasty chemistry formulae to run past me.
It's very good to see you again, Andy, even if it is just online. It's good, and we hope that you can come to Australia again sometime soon.
Well, if you can, yeah, okay. Well, if you can get the authorities to let Brits in. I think perhaps they are letting Brits in now. But
yes, they are now.
There was a few COVID problems, yeah.
Yeah,
okay.
yes.
No, yeah, I'd love to come again.
No one went anywhere for quite a while. I didn't go anywhere for quite a while, so I'm very happy to be back in the UK with all my wonderful colleagues here, and it's very good to see you.
Yeah, good to see you, Diane.
For that fascinating lecture. One thing I was going to ask actually is that in biology we have a lot of branching patterns.
Yes.
Yes, and I was wondering, is there a sort of mathematics behind? There must be mathematics behind those.
Yeah,
those are also beautiful.
Yeah, now there is an area of maths which I've not covered in this talk, which Jason Lyle has covered. And that is what we call Mandelbrot sets, where you get certain formulae, and again, it's to do with complex numbers, where if you do a repeated iteration on these number formulae, which I won't go into for the audience here, you actually get a strange pattern developing, which keeps on repeating itself. And he does a wonderful talk on Mandelbrot sets. Now, I don't know whether that's true within biology, whether there are some repeated patterns in biology.
Oh yes,
that you get where you get a mini. Yeah, where you get a mini leaf which looks the same as a larger leaf, except in miniature. Yeah. So I think that we call that basic similarity going down the scale, and I think that is represented well by what we call these number formulae, which Jason Lyle speaks about. So there are some interesting mathematical concepts in biology. Also, I showed you that the golden ratio definitely does occur in biological systems. So the answer is yes, I think there is a connection mathematically to the branching patterns that you were referring to.
Yes, that just adds to the depths and the riches of it. So
yes, it does. You're right.
Yes. No, thank you for that. If anyone else has another question.
That's great. Thank you. That question up the back. Let's see if we can come down here. Here we go. See how long the microphone lead lasts.
As long as Simon doesn't ask me an awkward question, just keep that microphone from Simon Turpin. He'll wreck me.
I guess it's a point made a lot, but without God, shouldn't everything just be totally random? And if without a lawmaker and a lawgiver, how do they get round? I mean, I still don't understand how they get around the fact that there are laws, but there's no lawmaker, and the fact that if everything, I mean, it's the whole entropy thing, isn't it? But if everything started at random, and if everything happens at random, and there's no overarching supernatural being, then time should just happen at random. Everything should be random, so that everything would be going up and down and around at random, and the hands on the clock would just be going at random. They wouldn't be going in one direction. Everything would be happening at random. Totally.
Yeah. I don't know who was the questioner, but what's your name, sir? What's the name of the questioner?
Oh, Peter. Yeah. No,
Peter.
Peter.
Thank you, Peter.
I'm just wondering how they get around that. How they get around.
Yeah.
that.
Okay. Let me say then, Peter, is what you're saying is absolutely right. That actually the universe shows patterns, and it's obeying laws, and the lawmaker must be there to have actually put those together. People have shown actually that if gravity was just slightly more, if that big G that I referred to was just slightly more or slightly less, you'd have a very different system, and it wouldn't support life. That means that God has made things to be exactly right to support life. There's a number of areas which actually show this. So, but there are also these patterns that I've been talking about in mathematics. Pi is connected to E, which is connected to the square root of -1. Now, most of us think, well, why on earth would you bother with the square root of -1? Well, what's amazing is that you can build up a whole theory which helps you to describe what's happening in many phenomena which are found in nature. Well, where does that ability for rational understanding of the world around you, where does that come from? So I agree with you that the world is not random, that the universe is not random. But what I'm also trying to get across, Peter, is that our own thinking naturally leads us, when we're left to ourselves, to set up mathematics, which is beautiful in its own right. That's why I called this talk Science, Mathematics and Beauty. You might not think that mathematics is beautiful, but I certainly do see an incredible beauty in the maths itself. The world is lending itself to be understood mathematically. Where does that maths come from? It's got to come from God.
Great stuff. Thank you. Any other questions? Any final questions? Yes, over here.
Hello. Thank you for your really interesting talk. You might have just
Who is this speaking? Who is this speaking?
My name's Katrina.
Katrina, nice to hear you.
Thank you so much for your talk. It's so informative. You might have just answered the question between you and Peter, but I was wondering if you could pose a question or two to, right, my father is also an applied mathematician, and he's probably about your age, but he very
oh, you mean he's 21?
Yes, about that, yeah. But so say what would be the one question or two questions you would pose to somebody like that, who was an adamant humanist, who was very well studied, very highly educated, and saw the beauty in the patterns in maths, and really appreciated that, but yet didn't ascribe it to intelligent design from a creator,
Mhm.
what would be the
Well-
one or two things, if you just had a short opportunity to try and get them to question, to think about it, to consider it being God? What would
Well,
it
this question is the question that I delight in. Thank you, Katrina, because that's the very heart of what I'm trying to get across. I would ask gently your father or anybody else in that position, okay, it's great what you've done. You've understood the mathematics and the physics, or whatever it is you've been doing. But where does mathematics itself come from? And rather than, they will try and say, oh, well, it came from my brain. No, that's not correct, because I'm asking something which is more fundamental. Where does rationality itself come from? Because mud left to itself over 13.7 billion years, which is what they say is the age of the universe. And of course, I don't accept that. But mud on itself, or matter on its own, does not produce mathematics, which is a language, which is a very precise language. Okay? Think of mathematics as a language. Then my question to your father or to anybody else in that position is, where does precise language, which is what mathematics is, come from? Where does rationality come from? Where does the ability to think logically come from? And that is what led C.S. Lewis to doubt his atheism. And frankly, there is no answer. I once asked an Oxford student, because I did this talk or something like it at one of the colleges in Oxford, and I was amazed that this Oxford student could not grasp the very question I was asking. Just like Dawkins could only answer the same question to John Hawley by saying, my brain's just a lump of meat. He completely misunderstood the question, because we're not asking where does the brain coming from. We're asking where does mental ability, rationality, rational thought, rational discussion, where does it come from? And there is no answer. The humanist cannot answer at all that question. May I just say, Joe, as we close, my booklet, Are You Really an Atheist? I think, Joe, I don't know whether you've got any.
Yeah, I was going to say,
it-
Answers in Genesis are here, and they have their book table, and I know that they have some of that booklet at the back. They also, I'm informed by Neil, that they have a copy of the presentation which you've given tonight up the back as well. So if people would like to recap or review before the test comes, then they can grab hold of one of those.
Can I just say, Joe, that to Katrina, the very first point, or sorry, the second point in this booklet is atheism makes no sense of original thought and rationality. I wrote this booklet, Katrina, for people like your father. So please do, if I was there, I'd just give you one. But Simon probably will say, no, you can't do that. Well, we'll see. Maybe he would. I like Simon very much, and I'm sure he will. There's also another booklet, Is It True? Evidence for Creation. Stuart Burgess and I produced that. So that's not right on the target tonight, but that might be relevant.
Great stuff. Thank you very, very much, Andy. I think we're going to have to leave it there, but thank you ever so much for, I'm down here now, hello. Thank you very, very much for joining us. It's been absolutely wonderful. Let's all give Andy a round of applause.
Yeah, and tell Simon I'll try and be early on Saturday. I'll see you.
Great stuff. Thank you very much, Andy. I'm going to come back onto the stage now.
The Lord bless you. I'm going to leave you now. Yeah.
God bless you.